We've been using the power of the wind for literally thousands of years. Think about it. Sails on ships, windmills, grinding grain, it's ancient stuff. But how did we get from that to the massive high-tech turbines that are a huge part of our green energy future? Well, that's exactly what we're going to explore today, the incredible journey of wind power. And this quote right here really nails it. Wind power is definitely not some newfangled invention. Nope, it's a technology we've been tweaking and perfecting for ages. But what's so cool is that right now, it's having this massive comeback, a total modern renaissance. All right, so here's our game plan for this explainer. We're going to start with how this old school tech is making a huge comeback. Then we'll get into the nuts and bolts of how a windmill actually works. From there, we'll check out all the ways we're using it today, its kind of surprising role in creating future fuels, and finally, we'll wrap up with what this all means for the bigger energy picture. Okay, let's kick things off with that comeback story. It's actually a pretty fascinating journey, right? How a simple machine for grinding grain turned into this cornerstone of our entire global energy strategy. And this timeline lays it out perfectly. I mean, look at this. We start about 3,000 years ago with really basic but super important stuff like pumping water and grinding grain. Then, fast forward to the late 1800s, bam! We get the first big leap, using wind to actually make electricity. Then the 20th century rolls around, and onshore wind farms start popping up more and more. And that brings us to today, where we're pushing the boundaries, heading offshore to capture even stronger, more consistent winds out over the ocean. All right, so we've got the history down. Now, let's get into the good stuff, the hardware. This is where we're going to geek out a little on the really clever engineering that takes something you can't even see, the wind's energy, and turns it into actual, useful work. So, what's the big idea here? At its most basic level, a mechanical windmill is just a brilliant energy converter. That's its whole job. It takes the wind's straight-line movement, engineers call this translational motion, and it masterfully converts it into a back-and-forth pumping action. What they call reciprocating motion. It's such a simple but totally elegant solution, and it's been working for hundreds of years. And it all starts right here, with the rotor blades. These are probably the most important part of the whole setup. Their special shape is absolutely critical for grabbing the wind's energy as efficiently as possible. I mean, they're the first thing the wind hits, so they have to be incredibly tough. We're talking materials that can resist all kinds of corrosion and wear and tear from being out in the elements 24/7. Okay, so once those blades start spinning, all that rotational energy gets passed onto this thing, this slider crank disc. You can think of it as the system's mechanical translator. Its job is to take that spinning motion from the blades and turn it into a smooth, balanced, straight-line motion. It's basically setting everything up for the final piece of the puzzle. And here it is, the final link in the chain, the connecting rod. This piece takes that straight-line motion from the crank and delivers the final punch, moving the pump's piston. It has to be super strong, right? Because it's dealing with both pushing and pulling forces. This is what completes that incredible energy conversion, turning invisible wind into something tangible, like life-giving water. Okay, so we've figured out the mechanics. We can turn wind into motion. Awesome. But now what? What can we actually do with it? Well, as you're about to see, the answer to that question is way broader than you probably think. So let's talk about those applications. They really run the gamut, from tiny villages all the way to massive industries, which just goes to show how flexible this old but new tech really is. And yeah, we're talking about way more than just powering the big electric grid. Wind energy can be a total game changer for local communities. Think about it. Pumping water for farms, bringing electricity to isolated villages for the first time, powering schools so kids can use computers. It can light and cool community centers, charge batteries for small businesses. It can even create totally new businesses, like making ice. It's really like a Swiss Army knife for progress. Of course, not all wind turbines are built the same. This chart breaks down the two main types. On one hand, you have the classic ones you always see, the horizontal axis turbines. These are beasts. They're designed for a super high coefficient of performance, which is just a fancy way of saying they're really, really efficient. The downside? They cost a lot up front and can be a headache to maintain. Then on the other hand, you have vertical axis turbines. They're smaller, cheaper, and way easier to take care of, but they just don't capture as much energy. It's this exact kind of trade-off that engineers are always juggling. Okay, let's shift gears and look ahead, because this is where things get really futuristic. We're going to see how wind power is moving way beyond just making electricity. It's becoming a crucial ingredient in creating a whole new kind of clean fuel that you can actually store. And that fuel is called green hydrogen. The idea behind it is actually pretty simple, but incredibly powerful. Basically, it's a fuel made with zero emissions. Here's how it works. You take renewable energy, like from a wind turbine, and use it to run an electric current through water. That process, called electrolysis, splits the water into hydrogen and oxygen. That hydrogen can then be stored and used later as a totally clean fuel. It's a huge deal for cleaning up heavy industry and hitting those big climate targets, like India's goal for 2070.
And this diagram just lays out the whole beautiful cycle perfectly. You see it right there, the wind turbine spin, making clean power. That power goes to an electrolyzer, which creates the hydrogen gas. Then you can store that gas and use it for all sorts of things, in fuel cells, as a way to transport energy, or even in industrial processes. It's this amazing, clean, closed-loop system that turns wind into a fuel you can use whenever you want.
Now, to help you get your head around just how massive this potential is, check out this number, 125 gigawatt hours. So a wind farm with that kind of capacity could make enough green hydrogen to replace all of the gray and blue hydrogen, the dirty stuff made from fossil fuels, that's currently used by all the industries in a country the size of India. I mean, let that sink in. That's a true game changer. So, we've looked at the past, the present mechanics, and the incredible future potential of wind power. What's the big takeaway? What's the one thing you should remember from all this? Well, if there's one key insight, it's this. Wind power's greatest strength isn't just making electricity, it's how incredibly versatile it is. I mean, this is the technology that can adapt and grow, all the way from a simple water pump in a village to the super complex processes that are going to create the fuel for tomorrow's green economy. And we'll end right there, on that question. Think about it. From ancient pumps to the fuels of the future, what's next? This ancient power source has proven over and over again that it's got a lot more to give. The next chapter for wind power, well, that's still being written.